Hello everyone, this is Jadsuda from Srivasavi Engineering College. I'm working as an assistant professor in EEE department. In last class, we have discussed about what is switchgear and what is circuit breaker, what is arc voltage, and what are the techniques to interrupt to quench the arc. So in this class, we'll discuss about expression for restriking voltage and triple RV. So the restriking voltage means at the stage of arc extinction, the voltage appears across the two contacts of the circuit breaker. So the system voltage and the transient voltage combines with each other and appears as restriking voltage. After that, recovery voltage is produced. This recovery voltage is the voltage that appears across the inductor and capacitor, which is produced in the form of oscillations. So here, for deriving restriking voltage, we'll take one feeder circuit which a fault appears near to the circuit breaker. Before the fault, normally the current flows through the circuit breaker contacts. These two contacts are attached with each other. These two contacts combine with each other. Whenever fault occurs, circuit breaker contacts are separated. Then at that time, the current flows through the circuit breaker will flows through this capacitor. Means the voltage appears across the circuit breaker will appears across this capacitor. So if we find the voltage across the capacitor, that will be the restriking voltage which is produced across the circuit breaker. So for obtaining this restriking voltage, so we'll apply KVL to the L and C circuits. So the voltage across the inductor can be written as L into di by dt, and the voltage across the capacitor 1 by C integral I dt, and the total voltage is E. So E equal to L into di by dt 1 by C integral I dt. Here we are calculating only restriking voltage. That's why I am taking the voltage across the inductor and capacitor only. So E equal to L into di by dt plus 1 by C integral I dt. But here we can retain I as, here E is constant voltage. Depending on the oscillations produced, E will be constant. So I can be written as change in charge. Again, the charge across the capacitor can be written as C into capacitance into voltage across the capacitor. So C Vc. Then this di by dt can be written as di by dt equal to, so d by dt of d CVC by dt. So it can be written as d square CVC by dt square. So it can be expressed as C into d square Vc by dt square. And then this 1 by C into integral I dt can be written as this 1 by C into again C V C, means integral I dt you can written as Q. Then this will be Vc. So these two expressions, this di by dt and 1 by C integral Vc can be substituted in this equation. Then we will get, by substituting these values in first equation, we will get the expression C d square Vc by dt square plus Vc equal to E. So we can apply inverse Laplace transform here. Then we will get the expression LC into S square Vc of S plus Vc of S equal to E by S. By taking Vc of S as common, 1 plus LC S square equal to E by S. Vc of S can be written as E by S 1 plus LC S square. Then LC as common, then S square plus 1 by LC. Here Vc of S. Then we can substitute omega n equal to 1 by root LC and omega n square equal to 1 by LC. By substituting this 1 by LC in this above expression, we will get Vc of S equal to E by E omega n by S into S square plus omega n. Then we can apply inverse Laplace transform to the Vc of S. Then Vc of t equal to this omega n by S square plus omega n is integral sin omega t. Then E integral 0 to t sin omega nt. So this we can get omega nt dt. Then E, this sin omega n can be written as cos omega nt minus cos by omega n with 0 to t limits. Omega n cancel, then E into, by substituting those limits, 1 minus cos omega nt. This is Vc of t. So this is the expression for restriking voltage. So this is the expression for restriking voltage. Then the maximum value of restriking voltage can be written as 2 into E peak. So this is the E peak, this is the 2 into E peak is the maximum value for restriking voltage. Then rate of rise of restriking voltage can be written as rate of rise of restriking voltage can be written as d by dt of Vc of t. d by dt of Vc of t. So this Vc of t is the derivative with respect to the t. Then d by dt of E into 1 minus cos omega nt. Then E is constant, 1 is 0, this cos omega nt is omega n into sin omega nt. So E omega n into sin omega nt is the triple RV, rate of rise of restriking voltage. Then for maximum value of triple RV is the E into omega n. So this is the maximum value of triple RV. Here omega n is 1 by root LC. So this is about restriking voltage and triple RV. So here there are two techniques to decrease the restriking voltage and triple RV. Those techniques are, one is resistance switching and current chopping. So first one is resistance switching. In this resistance switching, we can place one resistor in parallel to the circuit breaker terminals. One resistance in parallel to the circuit breaker terminals, and here is spear gap. Here spear gap is maintained to switch on the resistor. These two are the fixed and moving contacts of circuit breaker. Fixed and moving contacts of circuit breaker. So whenever a resistance is placed in parallel to the circuit breaker contacts to pass the recovery arc voltage and current which is passing through the capacitor will pass through this resistor. This process is known as resistance switching. So at this time, that extra current at the time of arc extension, that extra current, that restriking voltage will pass through this resistor. That extra current will pass through this resistance. Resistance is inversely proportional to current. So whenever the current is high, automatically after passing through resistance, the current will be decreases. So automatically restriking voltage will be decreases. Then triple RV can be decreases. So then the resistance is operated with the help of spear gap. Before the fault, these two contacts are attached with each other. After the fault, at the time of arc formation, these two contacts are separated with each other. Then spear gap is formed. By that gap, this resistance is activated. So in this way, this resistance is activated. So here we this recovery restriking voltage at this time appears across this resistance. So we have to find out that restriking voltage. This also can be solved by equivalent circuit. So severe gap, resistance. So here the fault. This is the circuit breaker C. Here VC. So here L. This is the supply voltage E. So here normally in before condition without this resistor whole transient voltage appears across L and C. But here this transient current also flows through this R. Here I is split into two currents, IR and IC. So by applying KVL to this equivalent circuit, we will get L into di by dt plus 1 by C integral I dt plus here R is there. So 1 by C into 1 by C into integral I dt equal to E. Here I is split into two currents, D into IC plus IR by dt plus 1 by C into integral I dt. As usual, we can write L into dic by dt plus L into dir by dt plus 1 by C integral I dt equal to E. So here L into dic by dt can be written as again di by d square dt by CVC. So here IC is dq by dt, here IC is dq by dt, here Q is again CVC by dt. So by this L into d square CVC by dt. Here IR can be written as d into VC by R by dt plus 1 by C integral I dt equal to E. Here 1 by C integral I dt again can be written as VC. So VC can be LC, C is constant, d square VC by dt plus L by R dVC by dt plus VC equal to E. So we can apply here Laplace transform to this equation. Then we will get LC into S square VC of S plus L by R into S into VC of S plus VC of S equal to E by S. By taking VC of S as common, then we will get LC S square plus L by R plus 1 equal to E by S. So for VC of S, by cross multiplying this equation, LC S square plus L by R plus 1. So LC as common, we will get S LC into S square. Here S is there. S square. Here L also. So 1 by RC S plus 1 by LC. So here the denominator root should be real. So then only we will get no transient voltage across the resistance. If these are not real, then arc will remain occurs. If we apply this b square minus 4ac rule, then we can write 4r square c square minus 1 by lc equal to 0 or greater than or equal to 0 like that. Or we can write 1 by 4r square c square is greater than or equal to 1 by lc. Or we can write by cross multiplying this equation 1 by r square c square is greater than or equal to 4 by lc. Or by this we can apply by cross multiplying this we can apply. So lc by r 4 c square r, then r is less than or equal to cc cancel, then we will get 1 by 2 into root L by C. So there are so many conditions. One is R infinity and one is R is greater than 1 by 2 root L by C, or is less than or equal to 1 by 2 root L C. These are the three cases for resistance. If R is infinity, if R is infinity, then the transient voltage or recovery, this recovery voltage is as usual like this. If R is greater than 1 by 2 root L by C, somewhat the transient voltage is decreased. So this is the recovery voltage and this is the restriking voltage. If R is less than or equal to 1 by 2 root L by C, so the waveform will like this. So there is no transient oscillations. So this is the restriking voltage and this is the recovery voltage. So the waveform will be smooth. So for in resistance switching, R should be placed with the value is less than or equal to 1 by 2 root LC, then only arc will not forms again, will not raises again. If R is greater than or equal to 1 by 2 root LC, arc will remains formed. So for arc extinguishment, so the restriking voltage for smooth waveform or to reduce the transient oscillations, you have to maintain R less than or equal to 1 by 2 root L by C. Here the frequency of oscillations can be written as 1 by 2 pi 1 by 4 LC, sorry 1 by LC by 1 by R square C square, 4R square C square. So here it is the equation for frequency of oscillations, transient oscillations, which is produced in the arc at the time of arc extinguishment. Next one is current chopping. So current chopping means, so this is the second technique to reduce the restriking voltage and to reduce the arc and to reduce the transient voltage or to reduce the oscillations formed. Here whenever low inductive current passing through this arc formation, this arc voltage, then the capacity of circuit breaker, the capacity to quench the arc of a circuit breaker is more than necessary to pass the low currents, low quantity currents. So at that time, the voltage which is appears between the two contacts, the voltage which is appears between the two contacts, which is stored in magnetic field, is formed across the capacitor as electrostatic field. The energy stored in magnetic field is half Li square and the electrostatic field is half Cv square. Here, if low inductive current is formed, flows, then the withstanding capacity of the circuit breaker is more than necessary and the voltage is converted into magnetic field of energy into electrostatic field. So these two energies are equal here. Then we will get half cancel, then Cv square equal to Li square, then V can be written as I into root of L by C. So this much of voltage is appears across the capacitor. So in normal condition, if arc is formed, the waveform is like this. So whenever this voltage appears, some prospective voltages appears across the breaker terminals. Thus voltages should be less than the voltage is less than the withstanding capacity of the circuit breaker, withstanding capacity of the circuit breaker. So here it is the withstanding capacity. Here it is the arc voltage. So these three are the prospective voltages. So whenever V is greater than the withstanding capacity, so arc doesn't extinguish. Whenever this prospective voltages are appears over the withstanding capacity, then arc doesn't extinguish. Whenever this V is less than the, this prospective values are less than the withstanding capacity, then arc will be extinguished like this. So there is no restriking voltage here, there is no arc here. Like this, current chopping works to reduce the restriking voltage and triple RV. So here these two are the techniques to reduce the restriking voltage at the time of arc formation. So here we can go through circuit breakers. So circuit breaker, as we know that circuit breaker plays a very important role in switch gear, in protection. So here there are so many circuit breakers are used. One is oil circuit breakers, air blast circuit breakers, SF6 circuit breakers, and vacuum circuit breakers. These circuit breakers as named as, so by the dielectric medium what used in that circuit breaker. If oil is used as the dielectric medium, then that is known as the oil circuit breaker. If air is used as the dielectric medium in circuit breaker, that is known as the air circuit breaker. If sulfur hexafluoride is used as the dielectric medium, then that is known as the sulfur hexafluoride SF6 circuit breaker. If vacuum is used as the dielectric medium, then that is known as the vacuum circuit breaker. So first, usually oil circuit breaker are used, so in substations or any other applications. So this oil circuit breaker have as like a normal circuit breaker, two contacts, one is fixed contact and another one is moving contact. In oil circuit breaker, total circuit breaker contacts are immersed in oil. This oil dielectric strength will useful to quench the arc. So here the some advantages of oil circuit breaker. Here oil has good dielectric strength, and oil acts as a good cooling medium, like insulator and cooling material. So also it this oil helps to cool the total circuit breaker surface. So here some disadvantages of oil circuit breaker. There is this oil is inflammable, so there is a risk of fire, and this will explosion with this there is a chance to chance for explosion because this oil with mixed with air. And this while arc quenching, these carbon materials, in deionization process, the electrons and ions or some carbon particles is diluted in oil. So there is a need to check, periodic check need in oil circuit breaker to change the oil. So in oil circuit breaker there are types of some classification is there. One is bulk oil circuit breaker and minimum oil circuit breaker. In bulk oil circuit breaker, again classified into two types: plain break oil circuit breaker and arc control circuit breaker. Again arc control circuit breakers are classified into two types: self blast circuit breaker and force blast circuit breaker. So coming to plain break circuit breaker, here also two contacts are there. One is fixed contact and moving contact. Here double break mechanism, by double break mechanism it is operated. Here two breaks are there. In normal conditions these two contacts are connected with each other. Whenever fault occurs, these two contacts are separated with each other. Arc is formed in between the two contacts like this. Arc is formed like this. At this time this oil have good electric strength and is greater than the arc capacity is greater than the arc voltage. This oil helps to quench the arc or to split the arc by increasing the length of the arc, or by splitting the arc by increasing the electric strength of the oil greater than the restriking voltage. At this time this oil may exploded up, the oil may moves up. So for this to reduce the chance of explosion, here ventilation ducts are there, like here air cushion is there. This air cushion helps to ventilate the this total circuit breaker. So if heat is dissipated, then there is a chance to dissipation of heat through this air cushion, and this oil level also will be remains constant after the arc quenching, and we can change the oil after arc extinguishment. So this is about plain circuit breaker. And also this plain circuit breaker, some limitations are this only used for low voltage applications only, but and no special control over the arc. So there is no arc control here, and this it has long and inconsistent arcing time. The arcing time is inconsistent in this plain oil circuit breaker, and this also not permit high speed interruption. So again, next one is self blast circuit breaker. Self blast circuit breakers are three types. One is plain explosion part, cross jet explosion part, self compensated explosion part. So in plain explosion part, the arc length of the arc is increased. So here also two contacts are present. These two contacts are immersed in a oil and fixed in a closed chamber, closed pot. So here whenever fault occurs, these two contacts are separated with each other, and the arc length of the arc is increased by moving the moving contact at some distance. And at this time the arc length is increased, so the strength of the arc voltage is decreased. So at that time arc will be extinguished. So next one is cross jet explosion part. Cross jet explosion we will discuss in next class. Thank you.